Hi, and this is section 4-4, and it's entitled Finding Slope and Rate of Change. I'm on page 235 of your book. I'll give you a second to get that. And again, slope and rate of change. The first thing we would need to talk about here is what is slope. So you can see I wrote a little something out here. You might want to consider, or actually I would say write this down in your notes. Slope, what slope is in algebra is it shows how rapidly a line is rising or falling. We use a number or a fraction to describe how fast the line is rising or falling. So slope is a number which will show us or demonstrate to us how fast a line rises or falls on a graph. All right, now there's a couple things we should know about slope and about this number, okay? When a line is rising, like the one I've drawn here, it has a positive slope. So the number that would represent this line would have to be a positive number because this line, as you can see, is rising right now. And for whatever reason, my pen stopped working for a minute. Hold on a second. I can there we go. Had my pen freeze on me. Actually, I should erase. I didn't want to do that. I wanted to erase this little green mark. I'm not sure why it's there. There we go. Okay. Next, I drew a second line in blue. And as you can see, this line is falling. A slope for a falling line would always be a negative amount. Okay, a slope for a falling line would be a negative amount. So if I had the number for the slope of this line, it would have a negative in front of it because you can see this line is a falling line. A third type of line that you will see is a completely horizontal line. A flat horizontal line has a slope of 0, has no slope, 0. And then there is a fourth kind of line that you will come across, and that would be one that's completely vertical. And I did this in green. A vertical line has an undefined slope. Undefined means there isn't a number that can represent it. Okay, when we have a vertical line straight up and down, we cannot assign a number to represent this line. If that's a case, we know it's vertical. Okay, there is no number that can represent a vertical line. It's undefined slope. Okay. Don't think there should be any questions on that, but those are the four basic lines you'll have. A rising line, which would have a positive slope, a falling line, which would have a negative slope, a flat horizontal line, which has a slope equal to 0, and a vertical line, which has an undefined slope. Now, let's talk about how we actually calculate this slope, how we actually find this number, which will identify the slope. And it's real easy to do. Slope, first of all, is a fraction. And it's a little phrase you can remember to help you with slope is rise over run. Rise is the numerator, run is the denominator. Okay, so here's what rise over run stands for. Okay, let's take this line that I drew, and I'm just going to identify 2 points on this line. Here's the point, -1, -4, and here's the point, 3, 4. I want to find the slope of this line. It's very easy to calculate. You start at the leftmost point. It's like reading a book. Go from left to right. This point is more left than this point, so I'm going to start here. I have to figure out the rise over the run, so let's do that. To get from this point to this point, I have to rise 1, 2, 3, 4, 5, 6, 7, 8 units. And I have to run 1, 2, 3, 4 units. My rise is 8 and my run is 4. So my slope would be 8 over 4, which equals 2 over 1. The slope for this line would be 2. A slope of 2 means every time I rise 2 units, now watch this carefully, if I rise 2 units, I got to turn this layer on. If I rise 2 units, 1, 2, I run 1, and I touch the line again. If I rise 2 units, I run 1. There, I'm at my line again. If I rise 2, I run 1. That's what this slope is telling me. It's telling me that the angle of incline, or I don't know what the exact words to use for that, but the amount of rise to run of this line would be at a ratio of 2 to 1. If I always go up 2 and over 1, I will keep getting back to this line every time. Okay? It doesn't matter if I would have picked different points. I'll use red this time just so it's easy to read. Okay? It doesn't matter if I would have said, let's start with this point, which is negative 2, negative 6, and let's go to this point. It doesn't matter because watch, I'm still going to get a slope of 2. This point, by the way, was 1, 0. I have to rise 1, 2, 3, 4, 5, 6, so I rose 6. And I run 1, 2, 3. Well, isn't 6 over 3 still equal to 2? I hope I'm making sense that it doesn't matter which 2 points I pick on my line, I will always find a rise to run ratio of 2 to 1. Okay? Let me erase these other things. Here's a second example of that. Okay, I want to find the slope of this line. I got to do rise over run. Now, in this case, I'm not actually rising, I'm falling, so I would use a negative number to represent that. I am going down 5, rising down 5, and running 10. Well, I'd use a negative number to represent my down 5. So I have negative 5 over 10, rise negative 5, run 10, which means my slope in this case is negative half. I believe this is an easy concept for you. It's just, even if you're not great at math, this is a simple concept if you're watching the video, okay? Very simple concept to figure out a slope. Now, there's a formula that you want to know to figure out slope also. And there's a reason why we want to know the formula. As you noticed on the last slides, you probably are like, well, why do I even need a formula? This is easy. I can just count squares. Well, you can if it's graphed, but look at the homework and go to questions 8 through 16 on page 239. I'm going to pause the video right here so you can go to that. Okay, I just paused the video and I'm back. You should be on page 239. Look at 8 to 16. Now, in those problems, they don't give you a picture. So here's the dilemma. Are you actually going to take a sheet of graph paper and draw this out? And I would hope your answer is no, because it's not worth it. You can quickly use a formula to find the slope. The formula looks like this. It's M stands for slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now the first thing we got to talk about is what in the heck is this y sub 2 minus y sub 1 and x sub 2 minus x sub 1? Where in the heck does this stuff come from? Okay, well here's what these little sub 2 and sub 1 symbols mean. The y sub 2 and x sub 2 mean this. It means that we have 2 points, and we are just calling the points point 1 and point 2. So one point I'll call x sub 1, y sub 1. That stands for just, another way of saying that is just this is point 1. And then x sub 2, y sub 2 is point 2. All I have to do is take point 1's xy value and point 2's xy values, plug it in here, and it will give me the slope. All right? It will just give me the slope. So again, what I normally do for this is I just call point 1 my ending point, point 2 my starting point, and I go, and that's how I set it up. This is super important for geometry. Now, I've taught geometry here at Frankenmuth High School. Mr. Keller teaches it right now. Mrs. not Mrs. Nettleman anymore, Ms. Bossack teaches it also. Either of those two people would tell you you use the slope formula basically almost daily in geometry. This is a formula you have to know. This is a formula I would probably put on my video audit tomorrow and say, I want to sit, just write down the slope formula for me. So yes, you ought to put this in your notes right now. Okay? What I want to do is go back to this first problem we did right here, and we already know the answer to this question was that we had a slope of 2. But let's go back and redo this problem using the slope formula. I had the point -1, -4, and I had the point 3, 4. Let's go back and let's do this problem again. We already know the answer is 2, but let's just show you that the slope formula works. We had -1, -4, and 3, 4. Okay, so here's what I would have done. -1, -4, I'll call that one of the points. 3, 4 is another point. So I'm just going to call this my first point, and here's my second point. It doesn't matter which point you call the first point and the second point. I'll show you that in a minute. Okay, let's use our slope formula. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so here's the deal. This point is my x sub 2, y sub 2. Here's what that means. Where I see the number 4, I got to plug that in for y sub 2, and you can see that I did that here. Where I see in my formula x sub 2, that's what my 3 represents. Do you notice that I took 3 and plugged it in for x sub 2? It's right here. And this point here is my x sub 1, y sub 1, which means where I see y sub 1, I put a -4. Can you see that? And where I have x sub 1, I put a -1 in. Well, let's quickly do this. 4 minus -4, I can add the opposite. 4 plus 4 is 8. And 3 minus -1 is like 3 plus 1, that's 4. Do you see how I got the same slope as what I got when I counted squares? I got a slope of 2, rise 8, run 4. Can you see the formula gave me the exact same thing? So no, we don't have to take out graph paper and draw these. We can make a quick calculation on paper. That's great. Now here's the thing. It doesn't matter if we had called this point 2 and this point 1. What if we called this the starting point and labeled it 2, and this the finishing point and labeled it 1? Okay, it doesn't matter. Watch. All that would mean is that instead of plugging, if I change this, now -4 is y sub 2, which would go here. -1 is y sub x sub 1, I misspoke. Let me say it again. -4 is y sub 2, that would go here. -1 is x sub 2, and that would go here. 3 is x sub 1, that would go here, which is here. And 4 is y sub 1, which would go here. Can you see how I'm getting -4 minus 4, which is -8? -1 minus 3, which is -4. Isn't a negative over a negative a positive? 8 over 4 is still 2. I'm getting the same thing. It doesn't matter which point you call sub 2 and sub 1, or which one you call point 2, point 1. You just have to plug it in the formula. You will get the same result either way. Let's do a problem in the book like number 11. It says, find the slope of the line that passes through these points. They gave me the point 1, 3 and the point 3, -2. So I decided to call this point my second point and this one my first one. So x sub 2 is 3. So where I see x sub 2, I got to put a 3. Y sub 2 is -2. Where I see y sub 2, I put in -2. And x sub 1 is 1. So where I see x sub 1, I put a 1. And y sub 1 is 3. Where I see y sub 1, I put a 3. And I quickly calculate. -2 minus 3 is -5. 3 minus 1 is 2. My rise over run is -5/2. I would always recommend keeping it in that form. Okay, I would recommend keeping your slope in fraction form. okay? Keep it in fraction form because that makes it easy. That tells me that I'm dropping 5 units on graph paper for every 2 units I run to the right. If you change this into -2.5, that's not always quite as easy to mentally wrap your mind around. This is simple. I'm dropping 5 every 2 I run. Question 12, we'll do one more. Okay, I got to use the slope formula. So I'm going to call this point my second point and this one my first point. So y sub 2 is 4, x sub 2 is 1. Did I say that right? I think I said that wrong. X sub 2 is 4, y sub 2 is 1. I might have been speaking too fast. Let me make sure I get that clear so I don't screw you up. Y sub 2 is 4. Whoa, I am screwing up. I better... I'm sorry, I just paused my video. I had to get my composure. I was screwing up. I don't know what I was thinking, and I just was talking and not saying the right thing. So let me go back to this again, because I said it wrong twice, and I must just not be concentrating. Let me try this again. I'll write it up here so I don't say it wrong this time. X sub 2, y sub 2. My y sub 2 is 1, so that belongs here. My x sub 2 is 4, and that belongs here. So you can see I put 1 for y sub 2, 4 for x sub 2. Let me slow myself down. Now let's go to the second point. So I don't want to screw you up, and I probably was screwing you up. My second point, x sub 1 is 3, y sub 1 is 4. So the y sub 1 would go here, and the x sub 1 would go here. So with that said, I have 1 minus 4. That gives me -3, and 4 minus -3 is +7. Okay? So my slope in this case would be -3/7, and that tells me if I drop 3 units on graph paper, I would have to run 7 to the right to keep on touching my line. Okay, so I apologize for, I don't know what I was thinking. I must have just lost focus there for a minute, okay? Keep on going here. Let's go to question 24. Here's another sort of problem you will see. In question 24, they will ask you to find the value of x or y so that the line passing through the given points has the given slope. So in 24, they tell us we have an unknown point, x4, a second point, 6, -1, and they tell me my slope is 5, 6. And you're probably like, well, what do I do to find out what this point is? Well, it's simple. First of all, write down the slope formula. Second step, I'm going to call this point 1, and I'll call this point 2, and my slope I already know is 5, 6. Okay? I'm going to take my points, let me label them so I don't screw up like I was just a minute ago. This point is x sub 2, y sub 2, and this point here is x sub 1, y sub 1, and I will plug that in the formula. So you can see that I did that. My x sub 2 is right here at 6. My x sub 1 is unknown, it's x. My y sub 2 is -1, and my y sub 1 is 4. Okay, and I wrote that down. Now, the key thing is m is 5, 6, so I can now write an equation. Since m is 5, 6, 5 6 has to equal, -5, do you see where I'm getting -5 from in the numerator, over 6 minus x. This is a simple proportion that you can now solve, and we did this earlier in Chapter 3. This is why I made a big deal about using cross products. Some of the shortcuts we were using will not work on this problem. So I'm going to cross product. -30 would equal 5 times 6 minus x. I can distribute and I have negative 30 equals 30 minus 5x, and now I got to solve. I can take away 30, which would give me negative 5x on the right and negative 60 on the left, and then I can divide each side by negative 5, and I'm finding out I have 12. That means the point, the value for x, this other point must have been the point 12, 4. Okay? One other thing we need to talk about here is rate of change. When you hear rate of change, that means we want to find the slope. And if you look at question number 19, it says the table shows the number of days you keep a rented movie before returning it and the total cost of renting the movie. Find the rate of change with respect to time and interpret its meaning. Okay, so when you see rate of change, that's a story problem way of saying I got to find the slope. So finding the slope, I'll use my slope formula. Now if you look at that table carefully, all I got to do is pick 2 points on that table. I'll pick the point 5 and 8.25. Now remember, 5 represents time in days, and I'm going to label that. 5 is days. 825 is the money or the cost, and 4 is days, and this is the cost. All right, well, let's plug this into my slope formula. I'll call this point 1 and I'll call this point 2. X sub 2 is 4, and X sub 1 you can see is 5. Y sub 2 is 6. Y sub 1 is 8.25, and when I subtract, 6 minus 8.25 is negative 2.25, and 4 minus 5 is negative 1, and I should cross this stuff out here. Okay, so I have negative 2.25 over negative 1. Well, when you solve that, that's positive 2.25. Now, here's the thing. Remember, rate of change is slope, but it's a real-life example of that. Now, these numbers in the numerator, these were my y values. Didn't the y values represent money? So that means the numerator represents money. And the x values in the denominator, didn't the x values represent days? Well, there's my x value representing days. So the rate of change in this problem would be the cost went up $2.25 per day. There's a rate of change. We'll do one more. Question 40. At least start you on number 40. It says, take a look at it. There's a graph they gave you. The graph shows the number in thousands of undergraduate students who majored in biological science, engineering, or liberal arts in the United States from 1990 to 2000. During which 2-year period in Part A did the number of engineering students decrease the most? So let's take a look at that graph. And you can see in the graph on page 242 that the engineering students are in blue. Now, if you look carefully, it looks to me like the biggest drop occurred from 1996 to 1998. I think you'd agree with me if you look at that carefully. I want to find or estimate the rate of change for this period. Now, to estimate the rate of change, that means get the slope. So I'm going to get the slope. I'm going to use the slope formula. Now, when you look carefully at that graph, it looks to me like in 1996, they had about 61,000 students. Now, you can see that there's a point for 1996, and this is the students in thousands. So it's a little bit past 60, so I call it 61,000. In 1998, you can see that the point is a little bit less than 60. So I put 58,000 students in 1998. So here are 2 ordered pairs. I'll call this my point 2, and I'll call this my point 1, which means, again, that this would be x sub 2, y sub 2, and here's x sub 1 and y sub 1. All I got to do is plug that in my formula. Y sub 2 is 58,000, y sub 1 is 61,000, x sub 2 is 1998, x sub 1 is 1996, and I solve, and I get negative 3,000 over 2, which is negative 1,500 over 1. Now, the numbers on top, remember, represent students. The y values were the students. This is a loss of 1,500 students, and since X is the years, this rate of change for those years was a loss of 1,500 students a year. Okay, I hope that made sense. I know this video is taking a little bit longer, so I'm going to stop it here. But we have now gotten through slope and rate of change.